Dennis Lee, and I want to talk with you about the prospect of us being able to actually produce a machine that would make free electricity. Electricity, by the way, with no operating cost. So we're not talking, when we say free electricity, about the concept of physics of getting more energy out of a machine than you put into a machine. We're talking, when we say free electricity, about being able to produce a commodity at no operating cost. We're not defying any of the laws of physics, and maybe you can just follow me here because we're not defying any of the laws of physics, and I'd like to just show you, I believe that magnets, little magnets, have lots of energy flowing through them. There's a flow of energy right here causing this not to fall to the ground, though it has weight, mass, and volume. And I think that that energy can be exploited. Now, supposedly magnets don't do work. So one of the reasons why people would have a hard time believing somebody could have a permanent magnet motor that ran a permanent magnet generator is that magnets don't do work. That's the theory. But if you take a look right here, as I said before, the magnet isn't doing work. But if you take a lump of coal, I have a question for people who think this magnet isn't doing work. And they're right, it isn't, because nothing is moving. But if I take a lump of coal and I set it on a desk, it just sits there. We can look at it all day long. It'll be just like this magnet right here. Nothing will be moving, it'll just be sitting on the desk. If I take a gallon of gasoline in a gallon container, set it on a desk, we just sit and look at it and look at it and look at it, it'll be just like this magnet. Nothing will be moving. Diesel. So let me see if I get the point here. Supposedly a generator that is a permanent magnet generator, a motor that's a permanent magnet motor, couldn't be used together, taking energy from magnets to do work, because magnets don't do work. But are you saying that a lump of coal sitting on a desk doing no work, are you trying to say that you can't take the energy out of coal and do work? Or you can't take the energy out of that gasoline and do work? Or you can't take the energy out of that diesel and do work? Or you can't take the energy out of this magnet and do work? Well, let me prove to you that you can. Now, what we have right here, we have a device. This device was made specifically to prove that magnets do work. Now, right here we have a bar magnet. That bar magnet is a south-facing magnet. This is a bar magnet. It's a north-facing magnet. So we have two bar magnets, and right through the center of that is a rail. If you were to see this sideways, you'd realize that this is the high end, that's the low end, and this is on a hill. So we have a rail on a hill between two magnets. Now, we're going to take a golf ball. This is a regular golf ball. That's a golf ball. Golf ball. Okay, now, golf balls, of course, are not going to be in any way affected by these magnets. If I drop that golf ball on my rail, we find that this is the high side, that's the low side. Why? Because balls roll uphill. I can push it up the hill, it'll stop and roll back down the hill. So the golf ball is proving to us that we do indeed have a hill here. This is the high side, that's the low side, this is two magnets. Now, we're going to take something a little bit different. We're going to take a little magnetic bearing, a little metal bearing. So this metal bearing would definitely be affected by magnets. I can prove that to you by showing you that's the magnet I had, that's the bearing. So Now we have a different situation. Now, this time, instead of taking the ball, putting it at the top of the hill and letting it roll down to the bottom of the hill, we're going to take our metal ball, put it at the bottom of the hill, and let it roll up the hill. Did you ever see a ball roll up a hill? Did you ever see that? Of course you did. You just saw it. I'm going to show it to you again. Put the ball right at the bottom of the hill, and the ball now will roll up to the top of the hill. All right? So, the magnets are pulling a ball up a hill. Tell me that that is not doing work. The concept that when I put a magnet on a piece of metal, it doesn't move, means there's no work being done, because work is defined by movement. But if I take a ball and set it between two magnets and it rolls it up a hill, then obviously I can, in some clever way, take the energy from the magnets and utilize that to do work. All right, now another example of magnets doing work, if you notice these really weird little objects out here just suspended in space, kind of interesting. That's a magnet there, and they're all attached to the wall. This one obviously isn't normally in that position because gravity for a ball is down, but kind of interesting, whenever it gets close to the magnet there, you notice that it's holding it up. Now, it isn't doing any work because nothing's moving, but certainly you can't tell me there isn't energy being expended here. Same thing here. If you look at this one here, see this? I mean, this is kind of neat. You may have a pair of sunglasses or something that you want to set up and just kind of like have them be held up by a magnet, because you notice, put my hands all around, my fingers all around this, this just being suspended in space out here, holding our little sunglasses up. This guy over here is pretty strong, very strong, and you notice that it's kind of, you know, he doesn't want to come off of here. You see that? Isn't that kind of a weird thing? I mean, magnets don't do any work or anything, but obviously there's some energy being expended. I mean, I can hold some really heavy stuff over here with this. Well, or just leave it up there. Anyway, magnets, as we've seen, can be used to do work. Magnets do expend energy. The problem with making electricity with magnets, this right here is a little unit that we built. It has, this right here is a magnet, and we have a lever, so you can just see the little steel lever going through here. Now, of course, steel is attracted to magnets, and so I have a keeper right here. If I pull this off, that steel is going to be attracted to the magnet. The magnet's going to pull it up. So that's causing a wheel to turn, which is how you make electricity. So the only problem is you'll notice when I lift this up, and when I take this keeper off, it's going to go straight up to the magnet and stop. Boom. So you only got a quarter of a turn. Now, obviously, if you had one here, 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 you could go quarters of turns, but once you get to this magnet, it's just held on there. I mean, you can't get it off of there. See, I'm trying to get it off. I can't. I can pick the whole thing up by the lever because I can't move it in any way. Now, so the idea here would be that if you could cause this to go to the magnet, and then the magnet could be demagnetized somehow, mysteriously. Some way it's demagnetized. But this is a permanent magnet motor, a permanent magnet. That means it's continually magnetized. So I can't just turn this off and demagnetize it. So the reason why people have a problem with people talking about a permanent magnet motor is because how do you demagnetize those permanent magnets that you've got? You can't, because you can't block a magnetic field. So you can't do it. It's physically impossible to block a magnetic field. Or is it? Well, I don't know. Let's talk about that a little bit, because if I could block this field,
I could neutralize the magnet, and then this lever would go past the magnet on up to the next one, neutralize that one, on around, on around, on around, on around, 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 and just sit and run and run and run and run. But this isn't an electromagnet. If it was an electromagnet, I could just pull the electricity away from it, demagnetize it, put it back, and so I could pulse this and cause the wheel to go around, or the lever to go around. Now, let's talk for a minute about the fact that we cannot shield magnets. Now, this right here is two magnets. They're very, this is two separate magnets. They're so bound together that you can't pull them apart with your hands. It would take 100 pounds of pressure to pull these apart. They are apart. They're not just one a glued magnet or anything, and I can prove to you that I can pull them apart with these levers. So I'll show you with the levers. This is two separate magnets. So you see, I mean, it is two separate magnets. You can pull them apart with the levers. But I'm going to do something kind of interesting with these two magnets. So they're together. This is a piece of copper. Now, copper is non-magnetic. So if you look down through the middle of it, just a piece of copper. And it's a lot of copper, and it's real thick, but it's non-magnetic. You see, the magnets don't stick to it. Magnets do not stick to it. So it's totally non-magnetic. Now, if I were to drop these magnets a couple of inches, like 6 inches, it takes a second, a fraction of a second, for them to fall. But watch what happens when I take these magnets and I drop them through this non-magnetic material. Boy, anticipation. There's your Heinz ketchup for you. Takes a long time for it to drop through here. Now, by the way, I can just come over here closely, and we'll just go ahead and just turn your camera down. And I can show you this. We'll just drop them right through. Here they are. And you see how slowly they go down there. And by the way, if I hold these magnets with my fingers up in this, and I try to pull them out, there's a lot of pull against this. What's that pull all about? And if I hold them like this up against this copper, I can feel a magnetic force field. It's like it's magnetic. Why? Well, the definition of this, by the way, this is called hysteresis. I'm not showing you something that science doesn't know. I am showing you something that most people don't know, but it's known to science, this phenomenon, non-magnetic material, but you can feel this field, and also when it's going down through here, why does it slow down? Well, it's just like Santa Claus. When Santa Claus goes through your chimney, he doesn't just fall straight down, he'll hit his bum. Instead, what he does is he lowers himself down on the sides. His arms and legs are lowering him down the chimney. The same way here. This is giving off a magnetic field. There's a magnetic field all around this magnet. So when it goes down, it's actually reflecting the magnetic field against the sides. That's what's slowing it down, and it's taking a long time to get in. So you might say this is bouncing back the magnetic field. You can feel it. It's bouncing back or reflecting the magnetic field. Now, that's kind of interesting, and that's quite a discovery, because if you can't block a magnetic field, what is going on right here? Now, I'm going to go a little bit further than this, and I'm going to give you a much better demonstration of that phenomenon. This right here is a bar magnet encased in plastic. So it's a bar magnet. We don't want people to get into all of our stuff of how we do what we do. And so this is all encased in plastic, but you notice it's plastic, 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 plastic all the way around. Bar magnet is magnetic on all sides and both ends. So all four sides and the two ends, it would all be magnetic. On this side right here, you will notice there's a very, very, very thick piece of copper. Very thick copper. Now we'll get back to that in a minute, but I want to prove to you that this is magnetic. This right here is just a piece of metal. It's not obviously itself magnetic, but if you get it next to a magnet, okay, it's a piece of metal. Now, if I take this piece of metal, I put it on this bar magnet, it's magnetic. That side of the bar magnet's magnetic. That side of the bar magnet is magnetic. That side of the bar magnet is magnetic. The bottom of the bar magnet, magnetic. So on all 5 sides, magnetic. But watch what happens. Now, by the way, this is impossible. So since this is impossible, I just want you to see something. This side where we have this big thick piece of copper, when I set the magnet on it, when I set the piece of metal on it, it falls off because it's totally non-magnetic. Magnetic here, 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 and here, but no magnetic here. No magnet, not magnetic. So, but you see, you can't block a magnetic field, because if you could block a magnetic field, my goodness, you could maybe do something really weird to where the magnet at one time is attracting an arm, and at another time is not having any effect on the arm at all, and you're allowing the arm to go by. Just a little hint, just a little clue as to some of the things that people like to say are impossible that are indeed possible.
I want to tell you that magnets do indeed make electricity. How do you make electricity? Everything about electricity, you have to have a generator. The generator sends magnets past coils. That sets up the flow of electrons. You make electricity. So you make electricity with magnets. Now, a good illustration of that is this flashlight. Here's a flashlight. You can buy these. It's a magnet going through a coil, a winding of copper. So it's going through a winding of copper, and as it does that, no batteries, there are no batteries in this flashlight at all, but as it goes through the winding of copper, it produces electricity. Electricity. So it goes through, makes electricity. Now, as a matter of fact, just 30 seconds worth of doing this, and you have 22 minutes of electricity right here. There's a little capacitor, there's no batteries here at all, little LED light, and a magnifier. So there you go, making electricity using that concept. Now, if I take a magnet, I can actually take this, pass a magnet close to, and you see the light? So anybody who says magnets don't make electricity, that's preposterous. That's a preposterous stance for anyone to take. So people who say that magnets don't do work, it's just you didn't understand the concept of what value and tremendous value there is in magnets. Now, here we have 4 magnets here and 4 magnets there, 8 magnets in total. They're on pinwheels, little pinwheels. They're off center right now, so they're balanced, so they're not doing anything. But if I merely take them off center, the little bit of power it takes in my finger to merely move it off center, look at all the activity that we're getting here, back and forth with these magnets. You see how much activity is happening because I just merely moved it that distance? Well, we would be putting 1 unit of electrical energy into a device that gets 5 units of energy out of it. And so 1 unit of energy in, 5 units of energy out. Where are the 5 units of energy coming from? Well, they're coming from all of the energy that you have in magnets. A lot of energy is flowing there. Cause this to defy the laws of gravity. This guy right here, Alexander Graham Bell, you can close up on this, Mike. Alexander Graham Bell, this is actually a newspaper article from 1878 where Alexander Graham Bell was arrested for peddling telephones on the street corner. He was arrested for peddling telephones. And the quote in here says that
Any fool knew. Only he was taking money from gullible people, because any fool knows that you cannot talk over a wire. Any fool knows you can't talk over a wire. And so, the fact of the matter is, what did Alexander Graham Bell do? He proved that you can indeed talk over a wire. He proved it. And you send impulses in, they go at the speed of light, they get reassembled in the same manner that they went in on the other side, and you get sound. Really simple. So you can talk over a wire, I'm sure you all know. You can fly through the air, I'm sure you all know. All these things were thought to be impossible before someone really exploited the dynamic that was always there. Now, in that same way, we're going to show you some footage of some presentations that we gave, public demonstrations. We've gone on 3 national tours featuring our technology and our ability. We believe that we will ultimately be able to produce free electricity. We believe that. Now, to give you an idea what we've had to endure so far to prove that, this right here was from our tour in 1996. 1996, we went on a tour across the United States of America, telling people we believed that we had the technologies, the understanding to be able to exploit technologies to produce electricity at no operating cost. Not free in a physics sense, but free in an economic sense. No operating cost. Just like a solar unit makes free electricity, just like a waterfall makes free electricity, just like a wind machine makes free electricity, we believed then, and even more so believe now, that there are lots of ways to make free electricity. Anyway, we did a show in Washington, D.C. at the end of our tour in 1996. This is a gold engraved invitation. We sent it to all the members of the Congress of the United States. A cordial invitation to please attend a ball that we were holding at the end of this tour. Here is it says RSVP, respond by February 26, 1996. It was announcing a show to happen on March the 5th, 1996. Now, at this show that we set up for the Congress of the United States, we invited 1,400 government officials from the federal government. Very unique way for scamsters to act. We invited Janet Reno, we invited the President, we invited every senator, we invited every member of the House of Representatives, we invited all federal employees in Washington, D.C. to come to this show. To see what? To see that we have technologies and that we were developing further technologies that could completely eliminate the need for fossil fuel pollution in production of electrical energy. That's what we wanted to show our government. We wanted to make it clear to them that we were going to advance this no matter what happened. We showed them lots of technologies that would prove that we could win a war with the electric utilities companies were they to resist us in this. We said, good news, we're Americans, we love our country, we don't want to collapse the infrastructure of the United States. We're coming in a friendly way. Would you please deregulate the electric utilities? Give anyone access to the electric utilities grid. Anybody that wants access, private producers, independent private producers, would have access to the utilities grid. We were contacted by the Energy Commission for the Congress, and they asked what we wanted, and I said, we want you to deregulate the electric utilities, and I gave them, to make a long story short, I gave them until July of 1996 to do that, or, quote unquote, I do get a little brash, we were going to go do it for them. They never met with us in private session. They probably would not acknowledge that we had anything whatsoever to do with this, but I find the timing to be quite interesting. We gave them a 12-point plan for deregulating the electric utilities and gave them a deadline of July of 1996 to do it. And by the way, the deregulation that the Congress of the United States passed looks pretty familiar to me. And it happened on July 19th, 1996. Coincidence? Possibly coincidence. I took it as a sign that the government was willing to work with us, and I've been trying to work with them ever since. The second tour that we did, we went out and we built our units and tried to put some technologies together. Finally, in 1999, we felt very comfortable with the technologies that we have right now, a combination of a motor called the Hummingbird motor that utilizes the concept of magnetic energy. It's a permanent magnet motor. We took it on tour in 1999. We ran an ad, a full-page ad in USA Today newspaper announcing this tour in 1999. This is the paper, USA Today, September, I think 15th or 17th, September 17th. We went on tour. This is the September 17th paper. This is a full-page excerpt from that paper. Here's a blow-up of that same excerpt. So we ran a full-page ad in USA Today, and in this ad it said, tired of high electric bills, how about no electric bills? And we're talking about bringing a technology that will show them amazing things, far more energy out of a electrical device than is going in the form of electricity. Now, we're not talking about more energy out of a mechanical device than is going in. We're talking about more energy out of an electrical device than the amount of electricity that's going in. But there is another source of energy besides electricity, and that would be the magnetic energy. Okay, now, so right here we're explaining that, and if you close up right here on this sentence, America's Declaration of Energy Independence, it says, bring your own test meters and measure the devices for yourself. So it's an invitation to all skeptics, to all engineers, to all scientists in America, and here are the places where we did shows. 47 locations in the United States. We did 47 shows in 32 states, nationwide. We gave all the scientists in the country a full-page ad inviting them to come bring their measurements, their instruments, and measure. Now we're going to show you excerpts of that videotape, and you're going to see in these excerpts of a show that we did on the road, and we did allow everybody to come on stage and make sure that our instruments were correct and make the measurements for themselves. Nationwide, thousands of people came up on stage, thousands of people measured this, and their measurements were always proved that our measurements were accurate. So we did this show. We're going to show you an excerpt from it. We showed a permanent magnet motor. You put 1 unit of energy in from the batteries, you get 5 units of mechanical energy out of it. Horsepower, drive, mechanical energy. 1 electrical from a set of batteries, 5 units of horsepower or energy coming out of it. And by the way, there has to be another source of energy, because you can't put 1 into a mechanical device and get 5 out. There has to be another source of energy. That other source of energy was the permanent magnets that we have in our motor. That was the source of energy. So far more energy was coming from the magnets in that motor than were coming from the electricity to just manipulate it in the proper manner. Now, so we did that. We proved the Hummingbird motor nationwide, gave all the scientists in this country an opportunity to prove us wrong. Then we went on another tour, yet another tour, and the next tour that we took was in the year 2001. That was just last year. So just last year we went on national tour again. This time we ran, once again, a full-page notice in Newsweek magazine. Newsweek magazine. Here's my mug standing next to a Sundance generator and a Hummingbird motor. We did indeed show all of this stuff. We proved that you can run an engine without any exhaust whatsoever, and lots of other technical things that we did indeed prove, but we demonstrated the Hummingbird, the Sundance generator. We did not bring the Hummingbird motor with us. So we will show you an excerpt from that show next. So first the Hummingbird show, showing that we did indeed get 5 units out of mechanical energy for every 1 unit of electrical energy. And obviously there was more than 5 going into that unit, but only 1 from the batteries. The other 5, or maybe 6, were coming from the magnets themselves, for an output of only 5. Okay, if you do the math, it says in that footage 4 out, but it was a quick, hasty illustration, but if you do the math, it was 5 out for one end. Now, so on this next film that we have, the footage is the Sundance generator. We put the Sundance generator in front of an audience in every state of the United States. We advertised here. We were coming to all 50 states, every single state. You could go to the internet to find the location in the state that you're from. It was a challenge to all technical people, once again in September. Challenge to all technical people to come out and prove us wrong. We demonstrated and measured a 100% efficient electric generator. That, by the way, has never been done before in the history of the country. Now, if you've got a 100% efficient electric generator, that means you take mechanical energy, horsepower, and convert it to electricity 1 to 1. So for every unit of mechanical energy going in, you get a unit of electricity. Well, if our motor that drives it, the Hummingbird motor that drives it, takes 1 unit of electrical energy, puts out 5 units of mechanical energy, and then this converts 5 mechanical back to electrical, then 1 electrical in, overall, it would stand to reason, it's logical, there would be 5 units of electrical energy coming out. That's the whole point of showing this and proving this, is not to show anybody a free electricity machine, because the 2 of these have never been run together. But it is to show everybody them individually. This is the most efficient motor in the world. This is the most efficient generator in the world. We believe when we put the 2 together, we wind up with a free electricity machine. We demonstrated. Now there's also another videotape where we had a private conference with our dealers. We put the Hummingbird motor, this is a 50 horsepower Hummingbird motor, onto the generator, but we did not turn it on. We did this for a photo op that has never been run together. But you will see some footage of the generator going, and you'll see that it's a low RPM electric generator. You'll be shocked by what you see there. The faster it goes, the more electricity it produces. You'll see some footage on that. You'll also see how lightweight and small in comparison to a 40 horsepower motor this is. I pick it up with my own arms like this. You can't do that with a 50 horsepower motor. You need a crane to lift a 50 horsepower motor. You'll see that footage in here to make that illustration. You'll also see that this is a variable speed. You can go faster or slower with this. You'll see that with a foot feed, where you can go faster or slower. And obviously, you probably came to the conclusion that maybe you could even use something like this to drive a car. And on this footage, at the end of this videotape, you're going to see we have a 150 horsepower electric motor that is set to go in a car as an engine for a car that will run on the same drivetrain. And you would go faster or slower with the foot feed. You'll also see how that can be controlled. This Hummingbird process can be controlled with a foot feed. So you got some interesting things to see. You also will not see on this tape another technology that we do have. It's the subject of another videotape itself, and that is a technology called the Tornado engine. This right here is a Tornado engine. It weighs 175 pounds. It's smaller than a Volkswagen engine. It creates a tornado on the inside, uses the turbine blades to get incredible amounts of torque right out here on the shaft. As a matter of fact, this baby right here, 175 pounds, you won't believe this, but I'll tell you anyway, will produce 5,000 horsepower using nothing but water vapors. It rips the molecules out of water vapors and burns them. It's called the tornado engine. This is something that we have in the back room that we intend maybe at some later date to pull out for commercial applications for electricity. We can make that little hummingbird or that little Sundance generator, instead of 32 inches square, we can make it 8 feet by 8 feet. If we did that, it would produce 500 kilowatts of electricity, 500. And so it would be a half a megawatt, so 1/2 a million watts per hour. So half a megawatt. And this right here would drive it. So we could get enough power from this using water vapors to power a half a megawatt. Imagine one of these on one side, an 8-foot by 8-foot block generator in the middle, another 8-foot by 8-foot block generator, and another one of these tornadoes on the other end. Tornado, generator, generator, tornado. That whole package would fit on an 8-foot box trailer, and it would be a whole megawatt of electricity. So if you think what you've heard so far is crazy, enjoy yourself, watch the videotapes. Please take the time, see it for yourself, and understand that every piece of footage that you are looking at was seen by thousands and thousands, tens of thousands of people all across the United States in multiple settings in every state of the country pretty much, with scientists being invited with full-page challenges to come and measure. And so, bon appetit. I'll let you watch the videotapes and you can see for yourself exactly what we're doing. Now, over here, I'm going to show you the most efficient electric motor that has ever been built in the history of mankind. So tonight you came out to a meeting, and it is not a meeting from a university, but we are going to show you the most efficient motor that has ever been tested for an audience anywhere in the world. And all the people who came to these shows on our tour are the people we're showing it to. We are not taking this down to a university so we can impress some hotshot scientists so that we can stand out here and publish a paper or get everybody to tell us how brilliant we are, because we don't care about any of that stuff. What we're doing is we are the Wright brothers. We're going to fly our airplane for the general population. You people are going to see it happen, and you're going to know tonight that the most efficient motor that's ever been demonstrated was demonstrated for you before your eyes. And we're going to prove that to you and show you that and measure all the power. But then we're going to show you how we can use that in a practical manner to disconnect you from the electric grid. Now, this right here is a DC motor. This is a DC motor. Now, if you measure this, if I put my hand on it here, it's 4 inches deep. So that's only 4 inches deep. You can see how wide it is with your own eyes. It's about 10 inches across. So 10 inches across, 4 inches deep. If I pick it up with one hand backhanded, it weighs 10 pounds. That motor right there is a 10 horsepower motor. 10 horsepower. It's a DC motor, and I mean, it is a Leviathan. It's a lot more powerful than any package that size of any other motor you're ever going to see. Right here is batteries. It's a DC power source. So we have a DC power source. Now, if I had a 12-volt motor, I would only need one battery. The motor would say, why so many batteries? If I had a 36-volt motor, I'd only need 3 batteries. This motor is a 96-volt motor, so I need all the batteries for the voltage. I don't need the current, I just need the voltage. Matter of fact, after we run it here, you can come back here later on and you can measure the batteries and they'll be fully charged. So I don't need the current, I just need the voltage. Now, this is the power source for a DC motor, DC power source, and my associate is going to pick up the cord in the back. He will show you that nothing here is plugged into the wall except the meter itself, this meter here, and the scope. So the meter and the scope are the only 2 things that are plugged in. Other than that, that battery source is the only source of power here. Now, we've got a scope up here, and the reason why we brought a scope was so we could look professional, right? We could shock everybody and say, oh my God, man, these guys must know what they're doing. They got a scope up here. No, the reason we put a scope up here is there are going to be some people in the audience that can read a scope, and we want you to see what is going on in this motor here, because something really amazing is happening here, something that has not happened before, that is very, very, very atypical to DC motors. Now, for the people who can't read a scope, I'm going to explain to you what's happening so you'll think you understand it too. Now, over here there's a line, that's the median line. Now, the median line there, if I turn this motor on, when he turns it on, you're going to see spikes going up here. So you're going to get spikes rising above that line. That shows on a DC motor that power is flowing in that direction. Then you're going to see something really weird, because you're going to see spikes going in the down also. So spikes are going to be going down as well as spikes going up. And that is going to indicate that power is flowing in both directions. That's an AC current, power flowing in both directions, not one direction. That means that power is coming from the battery to the motor, going from the motor back to the battery again. So power is going to the motor and back to the battery. Now, alternating current flowing in both directions, that's incredibly atypical for a DC motor. But in this DC motor, by the way, we have scientists in our own staff who have a disagreement in exactly the way that we would measure this power, because they have a disagreement in exactly what this means. Since no one's ever done it before, that's typical. Now, some of our scientists say this is an alternating current flowing both directions. That's their belief, and we should measure it as such. Other scientists say, yes, it is an alternating current, that's undeniable, but they think that there's a DC component to it, like a DC pulse in it, so we should also measure that component as well. So what we've got up here is we've got 2 meters to measure the power, not 1 meter. We're going to measure the current with 2 different meters. Now, 1 meter will measure one aspect, the other meter will measure the other, so we're going to measure it both ways. We want to show you we're being conservative. We don't want to be outlandish in our conclusions, so we're going to measure it both ways. Then what we're going to do to show you that we're being conservative is, whatever this meter says it's using and this one, we're going to add the 2 together to just put both units together so we can measure the current going in. Now, the voltage is right here. We can measure the voltage. Now, over here we got a thing called a dynamometer. What is a dynamometer? A dynamometer is an instrument to cause water to go from the bucket, come in, cause resistance on this motor so we can load the motor. We can make the motor do work. With this dynamometer, it's a brand new dynamometer. It was calibrated on the tour. It's never been used on anything but this tour for this motor. And so if you wanted to bring your own dynamometer to our show in Houston, we'll put your dynamometer up here. We can calibrate it, no problem. But this one here is calibrated. Now, as we load it, you'll see the load right over here. Charlie can close up on this meter, and you'll see that the second line there is horsepower. So the second line is horsepower. Now, what we're going to do is we're going to dial this up, and we're going to put 3 horsepower, a 3 horsepower load on this motor. So as we run the motor, we'll have a 3 horsepower load. We can measure the current, we can measure the voltage, we can determine how much power we are actually taking from the batteries to run this motor. Now, before I do that, I just want to tell you something. Does somebody here know, anybody, how many watts there are in a horsepower? How many watts in a horsepower?
740.
740, 743, 760. Anybody else? 746. You win the prize. Right, exactly. There are 746 watts in a horsepower. Now, so if there's 746 watts in a horsepower, and I got a motor that is doing 3 horsepower's worth of work, what would the output of the motor be? 746 times 3, right? That would be 2,238 watts of output. So if I'm doing 3 horsepower, I'm doing 2,238 watts of output. Now, I'm going to show you the most efficient motor that's ever been tested in mankind, and if I measure the power in this motor, and the input power in this motor while it's doing 3 horsepower work is 2,238 watts, then I would be showing you a motor that is 100% efficient. So that would easily win the prize from the federal government for $15 million. Well, nobody's been down here writing me a check recently. All right, now what we're going to do then is we're going to turn this over to my associate so he can explain to more technical people how we're measuring the power. And then we're just going to go ahead and we're going to show you a test pattern here so you can, a pattern here so you can see that power is flowing in both directions. Then we're just going to go ahead and beef it up and put the load on it.
Okay, all of the power that comes to both the controller and the motor comes through a 50 amp, 50 millivolt shunt. Now, it comes directly from the battery to that shunt, so this can't be an inverter. What the picture you see here cannot be inverted current because it comes directly out of the DC battery. Now, what is a shunt? A shunt is like a resistor. As the current passes through it, you get a voltage drop. This meter right here is measuring the voltage drop across that shunt. This is set on millivolts, so we're measuring the millivolt drop across that shunt. 50 amp shunt, 50 millivolt. If you see 50 here, then there would be 50 amps going through there. If you see 1.0 here, then there's 1 amp going to the motor. So whatever you see here corresponds to amps. The scope is also hooked up across that shunt, so you're looking at millivolt on the shunt as well. You're looking at a picture of the current, and you'll see that there is positive voltage and negative voltage. In other words, the current is passing both ways through that shunt directly into the batteries. This is an AC true RMS amp meter, clamp-on meter. It's a very good AC meter, and that's going to measure the AC component. So the first thing I'll do here is go ahead and turn it on so you can see a picture of the AC current.
Okay, so right now you see the AC current. Go ahead and close up on it. He's just showing you the current pattern. See the flow up and down is flowing in both directions. So we have current flowing both directions. We're now going to go ahead and load this up. Let me get my eyeballs on here so I can see what we got. We're going to load it up to about, what, 3 horsepower, right? Okay, there's 0.5, 0.7, 1.4, 2.4, 2.8, oh, 322. 3.3, okay, there we got 304, okay, 3 horsepower. 3.1 horsepower, actually. 3.2. Okay, 3.2, what do you got? Slow it down about 3.1, that's close enough. 3.1 horsepower. So we got 3.1 horsepower going now. And now what we're going to do is we can take these meters and we can freeze them where they're at. So we'll freeze that one and we freeze this one. And now we can just go ahead and measure the current. On one of these meters, the first one over here, we got 2.03. On the second meter over here, we got 2.89. Close up on that, Charlie. So we add those two together. 2.89 plus 2.03 equals 4.92 amps times how many volts we got here?
92 volts.
92 volts times 92 equals 453 watts. So folks, we got 453 watts of power, and we're doing 3.1 horsepower of work. 3.1 horsepower, we're supposed to be having 2,300 watts of power input, so we can be 100% efficient, but instead we got 453 watts of power input. What's wrong with this picture? Go ahead and turn it off. What's wrong with that picture? 453 watts for 3.1 horsepower. How efficient is that motor? 453 input, 2,300 output.
About 4 to 1.
Yeah, about 4 to 1. Actually, it's more than that, but let's say 4 to 1. So now, we're talking about a motor here that would be how efficient? If it's 4 to 1, that would be 400% efficient. Now, isn't this interesting? All universities, all the research people in the whole entire world working feverishly round the clock to try to get that $15 million grant from the federal government, trying to get that 90% barrier, get past that. And we're showing you a motor right here that's 400% efficient. Now, you would say, wow, that's 400% efficient. I would say, no, that is not 400% efficient. That is not even 100% efficient. Because
We are measuring the power coming into this motor from the batteries, but that is not all the power that is coming into this motor. We're only measuring the power from the battery that we are using to practically use the power from permanent magnets, because this is a permanent magnet motor. This motor is a permanent magnet motor. Now, that means that this right here is where the power is coming from, folks. And we're probably putting in 5 units of power here, 1 unit from the battery to practically apply this, so that we can get 4 units of power out of the unit altogether. So I want to make it real clear to everybody that in physics, we are not over 100% because we can't be over 100%. You cannot get more energy out of a mechanical device than you put into it. But we're only putting 1 unit of energy from the battery, and we're getting 4 or 5 units of energy from God, from the electromagnetic forces of the earth through a permanent magnet. You want to feel the power of a permanent magnet? And how long does it stay magnetized? Forever. And how much power does it give you? You can use a permanent magnet to pick up your car. A permanent magnet has lots and lots and lots of power, but the reason why you don't use a permanent magnet to pick up your car is because it never lets go. And so if you picked it up, it would always now be a part of your car. So you drive around with a permanent magnet on top of the car because you can't get it to let go. So the reason why no one has been able to build a permanent magnet motor is because it would take so much power to overcome the field to get the power from the field that you wouldn't be ahead of the game at all. But you see, maybe we figured out a way to finesse the power in a permanent magnet to be able to engage and disengage it when we want to. And in that particular case, with this particular motor, we would be able then to exploit the energy in a permanent magnet, and we get something outrageous like what would appear to be a 400% efficiency. That's because we actually are getting a 400% efficiency. Close to 500% now. And we now tonight have got for you the Sundance generator. So we have a motor, we proved it in 1999. Now we're going across America with the most efficient generator that has ever been demonstrated for a crowd. And we're going to demonstrate it tonight. And we are going to prove to you now that we have the most efficient generator that has ever been built in the history of the world. Not only do we have the most efficient generator, we also have the best design generator that's ever been designed. I'll tell you why. If you have a generator right now, and you run the generator and the generator breaks, what do you do with it? Throw it away. That's it, you just throw it away. Because you can't do anything else, you can't repair it. Now you could send it back to the factory, they could rewind it, but if it was worth a lot of money you might, but if it's not worth a whole lot of money, then you just throw it away. Now this right here, this generator is designed in a very unique manner. You notice all these modules. These are all separate, independent modules. Now these modules are that very unique material in a U shape. On this side of the U, you have a coil. On this side of the U, you have another coil. This coil, as the magnets come around, makes electricity. This one makes electricity as they come around as well. So the core material is transferring the power from the windings. Now each one of these modules produces 1 kilowatt of electricity. So this module, independent of this module and that module, this one makes 1 kilowatt hour. Now what happens then is, if you look here, while it's running, if there was a little LED light up here, that's the way it will be designed, there's an LED light up here. When this one breaks a core or a coil, the LED light goes out and it says this is no longer making the 1 kW. There will be a quick disconnect at your house. You pull that one out, pick up another one, stick it right back in, just like you change a fuse at your home. And now it wasn't making any electricity, and then you pop a brand new one in while it's running. You don't even shut it down, and now it's making a kilowatt of electricity again. Now, if you count these, We'll start right there with the writing as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 of these modules. If each one of them make a kilowatt of electricity, how much electricity will that make? 15 kilowatts. If you go around to the back of the machine, there are 15 more in the back. So it's like this. Cores and coils like this, facing one another, with the magnets going through producing the electricity. So you're making 15 on this side, 15 on that side. How many kilowatts will the whole thing make? 30 kilowatts. So we said we were going to bring to your house a 30 kW generator. This is what it will be like. Now, in that, if you're running along and the LED light goes on, then you're making 29 kilowatts because this one's out. When you pop it out, you're still making 29 kilowatts. When you pop another one in, you're now making 30 again. You tell me that there's a better designed generator anywhere in the world, or that there's a more serviceable or easy to repair generator that's ever been built in the history of generator manufacturing. Now, our Hummingbird motor is designed to set right up here. Tonight I will show you why we never put the Hummingbird in the same room with the Sundance. We don't want to give them too big a target. So, but the Hummingbird motor would set right here. That would drive this, and it's about that big. That's it. That would be it. Now, this is made out of G10. The unit will come to you made out of G10. G10 is a material that will last for over 100 years. How long will this generator last? Over 100 years. You may have to pop out every module over 100 years and replace them a couple of times, but the generator itself is built to last for 100 years. You see, we build things to last. We don't believe in planned obsolescence. We believe in planned excellence. We're all set to go here. Now, on this, the driver will be up here. If the driver produces 5 units of horsepower for 1 unit of electricity from a battery source, I'm going to have to test this to see how many of those units of horsepower, what percentage of them can get converted to electricity. So you got horsepower driving it, but you're producing electricity. Now, normally you don't get very much. You put a generator set together, you got a driver and everything up there, you're usually lucky if you get 50% of the power converted to electricity. And so I'm going to test this for you tonight. Now, in the back here, we had to shorten this and not put anything out here, and unfortunately the motors that the rest of the world built are not small like our motor. So we couldn't put them out here and still get it through hotel room doors. So in order to get through hotel doors, we put in the back here a gear, and we have a belt on it. So this is going to be belt drive back here. We got a motor down here that we're using to run this, and this is an over-the-counter motor. It's a regular conventional motor. That is not a Hummingbird motor. That's a normal conventional motor. Since it's driving it on the belt, when we turn this on, it's going to make more noise than it normally would. Normally it would be very quiet. It would not make any more noise than a regular heat pump outside your house or an air conditioner. So that's the noise you would expect this to make. Now tonight it will make more noise than that because we got a gear over here with a belt drive, and that's a whole lot more noise than the direct drive we would normally have. Also down here we got a 20 horsepower over-the-counter regular motor, so we're going to drive it with that. Do we have one person in the room here that can come, or 2 or 3 or 4, that can come and look at this motor and tell us we have a 20 horsepower over-the-counter motor, just come and look it over, and tell us that it's hooked up the way any electric motor would normally be hooked up. There's nothing unusual about the driver on this system. Anybody? Anybody technical, come here and just look at this and tell us if it's set up right. Okay? Anybody else who wants to come, if you're technical, come on up here. We're also going to let you stand here while we test this.
What causes the modules to go bad?
A module will always go bad because a coil breaks. So over time, those copper coils will snap. And when it snaps, then it isn't getting the connection anymore. So you just pop it out. Wear and tear, heat, all those electrons going through it. Everything breaks over time.
May change the electrical shock while you're removing it?
Now, if you're removing it, it will be different than this right here. Now, the way we have it set up right here, anybody, if you want to, you can stay here when we test it and have a couple of experts here to watch this test too. Would you be willing to be here when we test it also as well, and just make sure we're testing it right? Now, so what happens is anything breaks over time, but they're so easy to replace. Now tonight, we're going to take one out while it's running. So we'll show you that you can pull it out, and it'll still stay running. You'll hear in your ear the noise before he pulls it out, and after he pulls it out, it won't change the sound at all. Then when he puts it back in, it won't change the sound at all. But he'll take it out. Now, we're doing that with not quick disconnects. We're going to use regular bolts in here with a power tool, because we're bouncing this in and out of stages in 50 states on a 17,000-mile tour. So I don't want quick disconnects because they can break. I just want to make sure I don't break this unit as we do it. So that's the only reason he's using a power tool. Normally we would have it set up with a quick disconnect. All right, now when we test it, let me show you what we're going to do to test it. What we're going to do to test it is right here we've got a box to measure the input power into the unit. So he will take his meter, he will measure the input power into the unit. We have a very, very, very sophisticated, good piece of equipment to test it. Ricky will explain to you what that is in a second. So he'll measure the input here while it's running. Then he's going to take the output over here and his live wires. This is three-phase. So he's going to measure the three-phase output here. By the way, you can have 220 in your house. No problem to split that off three-phase. And the load over here is going to be this load bank. We're going to have that load bank on, putting a load on it, so that he'll be able to measure the power output. So we measure the input, we measure the output, we pop one of these out and show it to you, put it back, and then we'll talk about what happened. Mike, are you going to be able to calculate it and take the numbers? Okay. He doesn't have his shoes on. You got enough feet and toes? No, you get it, you'll get it. All right. Okay, now, so Ricky's going to just tell us very briefly what we're going to be using to measure this.
It's an XTEX 600 volt MaxCat 3. It's made to calculate three-phase, three-wire, three-phase, four-wire, single-phase, whatever. You take each reading and it accumulates. So when you go to the last reading, it tells you what you were doing.
It also counts for power factor. Okay. All right, now we're also going to be loading it. What are we loading it with?
It's a 55 kilowatt resistive load bank that you can vary. It's much easier to bring something like that than it is, 22,000 light bulbs.
Okay, so we will use that as the load so we can measure the input and the output. So we're going to go ahead and turn it on. Now when it runs, it will make more noise than it would at your house because it's belt driven now on gears, and so it's making noise. Okay, go ahead. Now this is the load bank. Now he kicks the unit. John just talked about it for a while. We can see it at the end here. We'll let you look a little closer. At one of our shows, we had somebody put something into our wheel there, so we're a little bit sensitive about it. So we tried to sabotage this already once. Pulled around, it's going click, click, click. So in Casper, Wyoming, we didn't test it. It's the only place we didn't test it. Because every time you turned it, it was going click, click, click. Anyway, now, let's take a look at what we did. How many horsepower, how many watts are there in the horsepower? 746. We have a 20 horsepower motor here, and if we were getting all the power from a 20 horsepower motor, we should be getting 14,950 watts output from this unit, right? Because if you multiply that out, that's what you get, 20 times 746. Michael, we got how many watts output?
17,740.
17,740 watts output. Now, so 17,740 output, how much is that per horsepower divided by 20?
887.
So instead of 746, we're getting 887 watts per horsepower. That's kind of weird. But now let's take a look at the input. 22.64 input.
22.820.
22.820 input. That's 22,820 watts of power going in for 17,740
740.
out. How efficient is that unit?
77.7.
77.6% efficient. Now, this unit right here, the whole thing, is 77.6% efficient. The motor right there is made by Baldor. Call Baldor on the phone. Ask Baldor if you had almost 23 kilowatts of electricity going into that motor, how efficient would the motor be? You know what Baldor will tell you? 77% efficient. So, I got a question for you. If the driver is 77% efficient and the whole unit is 77% efficient, how efficient is the generator?
100%.
You got it, right on the nose. 100% efficient generator. We've shown that at every single show we've done so far nationwide. Now we got a 100% efficient generator. You've never seen one of those demonstrated before anywhere in the world. They can be 60%, but they can't be 100%. Now, reason with me. If I have a driver that I've already proven nationwide to be one from the batteries for 5 units of horsepower, I can take that horsepower, put it directly on a generator to convert horsepower to electricity, and it's 100% efficient at producing electricity out of horsepower. So my 5 units of horsepower become how many units of electricity? 5. So now, if I've got 1 unit of electricity coming from a battery to produce 5 units of electricity out of that combination, where would I get the 1 to put back into batteries again? How about that one? And then I would get 5 more units of electricity. 1 in the battery, 5 out. 1 in, 5 out. 1 in, 5 out. 1 in, 5 out. That'll make 30 kilowatts of electricity. Okay, and so that's what we're going to do for you. We're going to demonstrate the flexibility of this generator. It is a completely serviceable generator. Now, also, when he takes this out, what he'll have to do, we don't have these with the little finger screws on them, and so he's going to use a wrench to take them out because for the show here, this is our prototype model, and for a finished product, we'd have it in there where you can just pop them in and pop them out. But for now, we'll just unscrew it, and so he'll unscrew it for you as we're running, and he'll take it out, you can see it, and it's still producing electricity, then he'll pop it right back in again for you and show you it's the most serviceable generator that's ever been invented in the history of the world. Easily repaired as we operate. Ready to go? Okay, they're going to run it at low RPM. Now, we got an RPM gauge here, too. Here we have an RPM gauge, and while he's doing this, you can see the RPMs. It'll be running at probably about 300 or 400 RPMs. Is that about all we can go? It's about 300-400 RPMs.
it'll still be making electricity. When is the last time you saw a generator that's making electricity at 300 RPMs? 1600, 1800, 3600, but not 300. And so you'll see that's very unique because this generator will make electricity at the low end and the high end. The higher you take it, the more it makes. The lower you take it, the less it makes. And so it'll be lighting some lights with only 300 RPMs. And that's a very, very, very unique demonstration. Okay, ready? It's got to get calibrated there. 380. We had a 380. What do you got on top of here? 390. Okay. So it'll get smoothed out. There you go. 380. You get a reading every once in a while. It's lighting the lights now at 380 RPMs. 377. Just at these low RPMs, it just reads sporadically. 377. Now we're making light. He's now removing one of the modules. So as he takes the module out, it's still making light. This would be you saw an LED light go off and you said, okay, I better repair that. If we were selling electricity with this right now, what would happen is our indicators, our computers would tell us we're down in output. Right there is the windings. That's the windings in the motor. You see the windings? That's the windings of this motor. So to repair those, all you do is take them out. You got an empty hole, then you just put them right back in again. No problem. Then you put it back in, it starts generating electricity again. You can see the spark in that if you looked in close in that as you put it in. It starts making electricity again, no problem. It doesn't, you never, ever, ever have to shut this engine, this generator down to make electricity. Now this one right here has been tested. Thank you. Thank you. You got it. Okay, this has been tested to put out 30 kilowatts of electricity. So this size generator, 35 inches square, puts out 30 kilowatts of electricity. Now, if we had this unit at your house, it would put out 30. And the motor in the back is whining because we just got a motor. It's a brand new motor, and it has a bearing loose. And so you can hear the bearing in there about to go out in it. We got to take it back and let them service it. Brand new ball door motor, bearing is loose. But normally it would run quiet, you wouldn't have the noise because the motor doesn't really make a lot of noise. When you see this one run here, you'll see that it doesn't make a whole lot of noise either. Okay, hey, thanks a lot, guys. Thank you. So there is a very, 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 very flexible motor, generator. It is the most unique generator in the world, but it also makes electricity at any RPM, all the way up through the spectrum. That same unit, if we build it 8 feet square instead of 4 feet square, will produce 500 kilowatts of electricity. We've done all the testing, we've got all the data. We can get 30 kilowatts with this one, we can get 500 kilowatts with an 8-foot square instead of this 34-inch square. Now, hold that thought because we're going to get into showing you a thing that we lovingly refer to as the Power Wagon. Something where we can put out a lot of firepower on a 45-foot trailer using this same exact technology just in a bigger array. Now the next thing that I want to show you is the driver motor that would run it. If I can get you guys to just come back over here for a minute, Mark, and get Rick and all the firepower here if he's available. If we could turn that back again, because I'd like to make another point here. I want you guys to see this from the side angle. Yeah, take your time there. Yeah, you just got one guy on this side. Hold off. We just got one guy in the back there, so one person in the back, so you got to move that one first. Where'd Ricky go? Have him come and go. Tell Ricky, hang around. It's only 2 hours. Yeah, I think he's getting tired. I wore him out over the last 2 days. Okay, I want to show you this because I want you to be able to compare here. That's almost got it there. Maybe one more shot. I want you to be able to get, now watch, Rick will come here exactly as you get that last shot done. You watch. Old Rick will be coming up. Here he is. Is he coming? Hold it. You guys are almost done. Hurry, hurry, hurry. Okay, that's good. That's it. Okay, don't need you, Rick. I do get my licks back in, Rick. Now, so what was the motor that just drove this generator, or that would drive this generator? This is a 40 horsepower motor. Now, this is a conventional motor. This is what conventional science would give you. This 40 horsepower is driving this big generator right here. 40 horses. Believe me, that's very, very heavy. Nobody's going to pick this thing up. Even Rick isn't going to pick that one up. This right here is the motor that got here an hour ago on a 2,000 mile ride. This is a 50 horsepower Hummingbird motor. So this is 50 horsepower, this is 40 horsepower. Just to give you an idea about the size. This one right here, believe me, I would never do this with the other one. Horsepower. And if you notice that the back plate on here is the same size of the whole motor here. So imagine this motor mounted up here on this, and that right there. That motor and that generator is a home unit that will produce 30 kilowatts of electricity. Now this is the 50 horsepower here. This just got bounced 2,000 miles and Ron just came in. There we go. Okay, there's this 50 horsepower motor right here, same size. That would be the driver, just as efficient as the one we just tested. That one was set up to test. Exactly the same technology. And so over there you were seeing this input to output over here that was incredible. You would have that technology connected to that generator. And so here you are, and you can vary it. Ron can show you right here that if you even wanted to do something exotic like put this onto a car, he can show you how effective this can be. That's the foot feed. Now he went for it.
But the nice part about it is, it behaves like a regular gasoline engine. That's what I tried to do, is to duplicate it so that it would behave so that the little old lady from Pasadena wouldn't have to go to school to learn how to drive an electric car. Well, it drives just like a regular gasoline car. Just step on it and go. Electric motor. We've got the alternator, the vacuum pump, and the power steering pump.
Yep.
So everything in the car will work.
Everything in the car goes. And there we go, down the road. Down the road, Charles Perrault.
Okay, now I'm going to show you something a little bit different. You know, people talk to me about energy is not created or destroyed, and they act as if I don't understand that energy is not created or destroyed. Nikola Tesla developed a technology that more than proves that energy is not created or destroyed. And it's a technology that if the electric utility companies really wanted to have a war with me or war with somebody, we've got a device here. It's called the Negawatt circuit. And I think this could really give them fits, because what would you think of a device where you could literally have a little circuit, just a small circuit, be able to put it on your side of the box, and every light in your building that you turned on, more electricity that you turned on to use, the more you turned on, the more would be lit. You would have all your lights lit, but the more you turned on in your house, the more your meter said you were sending to the electric utility company, taking nothing from the electric utility company. What would you think of having a device like that you could install on your side of the meter, and it's perfectly legal to put anything you want on your side of the meter? Well, there is such a device, and that little device is called the Negawatt circuit. I have a hard-wired old copy of this. We built it based upon Tesla's theories and proved it. But people like to say to me, energy isn't created or destroyed, and they act as if I don't understand that. But I do indeed understand that energy is not created or destroyed, but I have a question for anybody who wants to throw that up in my face. And that is, if energy is not created or destroyed, and I agree, it isn't created or destroyed, but if you agree and energy is not created or destroyed, maybe you can answer a question for me. How do we consume electricity? How do we consume it? And the fact is, and the answer is, we don't consume electricity. And the fact is, and the answer is, we could send the electricity to your house, let you use the electricity, and then send it back to the electric utility company. That's a well-kept secret. Instead, it goes to your house, and then it goes through your bulbs and everything you use, and then it goes into the ground. Why? Because they don't want it back. Well, let me prove to you that we could send the electricity back to the electric company. Not only do that, we could also get your meter to run backwards without you even having any generating equipment. From the power they're sending you, run your meter backwards, and they would owe you money for all the electricity that's coming to your house. Let me prove that to you real quick. It's called the Negawatt circuit. Now, I've got it under lock and key here. So I've got to open this up. This, believe me, we do not keep this just laying around. The whole technology is in this box right here. It's hardwire. And by the way, literally, I won't let anybody videotape that, but all the stuff that's in this box could be picked up in any hardware store, or in any Radio Shack anywhere in the United States of America, to build what I'm going to show you right now. Now, to demonstrate this to you, this is one of the most sophisticated meters in the world. It measures the wattage, power factor, and it also measures, the voltage, the power factor, and the wattage. Now, when I dial this variac up, I'm sending the power through this box over to the first bulb. This is the way power works at your house. So if I light the bulb, run it up here to about 90 volts, I promised the guys in research I wouldn't go over 90 volts, so we won't. Mainly because the stuff in here is all hardwire, old transistors, and we don't want to ruin them. So 92 volts, we have a resistive load, which always gives you a power factor of 1. Have a power factor of 1, resistive load, 90 volts, and if you look, we're using about 68.9, 69 watts of power. Well, we got a 100-watt light bulb, and it's not fully lit because I want to protect all of the hard stuff in here. This will go in a museum someday. Now, let me dial that back down, shut it off, and I'm going to take the bulb out of this circuit because this circuit actually, the power goes through this device, this negawatt circuit, to this bulb. So I'm going to use the same exact bulb over here so that nobody accuses me of having a trick bulb. Anybody can come to our facility on an open house and you can see this demonstration up close and personal, except people I don't like. Now the power is going to go through this circuit and to this bulb. I'm just going to change this over, and basically when I send the electricity, you'll notice, send the electricity through, and if you listen carefully, you can hear it chirping away. You can hear it humming. I don't know if you can hear that or not, but it is humming now. And I'm going to run this up, by the way, to 90, as I did before, 90 volts. So I've got a resistive load of light bulb. I'm at 90 volts, but look at the power factor. The power factor is minus less than 0. Power factor for resistive load is always 1, but power factor of less than 0 minus see how many watts we are consuming or with our meter is saying this light bulb fully lit is not taking any electricity from the electric utility company. But if we look back at our meter, it says that this bulb is lit, we are sending the electric utility company 30 watts of power. So minus 30, that means power flowing that way, back to the electric company. And the meter is it's using any electricity. Lit, and we're 30 watts of power to the electric company. And it's all because of the circuit that we have inside of here that can be reduced, by the way, to a little circuit about this size, solid state, that I could build for about $40, and I could put one of these on every home in America for about an $80 or $100 bill and get more than double my cost for manufacturing it. If there ever was a reason for me to have a war with the electric utilities companies, believe me, this right here would probably be the first device that I would employ. However, I'm not here to have a war with the electric utilities. I'm here to work with the electric utilities and use their grid. And by the way, I want you to understand something. I don't need the electric utilities grid. Power can be sent anywhere without any wires whatsoever. Let me show you that technology next. I'll do a demonstration. Once again, Mr. Tesla, that's why we call our project the International Tesla Electric Company, because actually Tesla had a plan for making free electricity, distributing it worldwide or at least nationwide in the United States of America, and he could have done that in the very beginnings of the electric utilities industry. So there's no reason why we haven't had free electricity the entire history of the electric utility industry. So when somebody says I'm being unfair with the electric utilities, look, they've had over 100 years of charging people for what Tesla could have given to us absolutely free 100 years ago. So now I'm not wanting to be in any way mean or vicious with the electric utilities, and I want to work with the electric utilities industry. I want to work with the current suppliers of power. I want to send low cost, non-polluting, green energy from the homes in America back into the utilities grid, send them over the wires, and use the grid that the electric utilities companies have, pay them for the use of the grid, or sell them the electrical energy, let them mark it up, sell it to the consumers. And why am I so concerned about that? Primarily because the electric utilities grid, there's one reason and one reason alone why we need it, other than the fact that it's already there. One reason why we need it, and that is because our entire economy and the infrastructure of our country is connected to the grid system. So we are connected to the utilities grid, and if that grid went down, even though we might still be able to get all of our power, we could collapse the economy of the United States. If somebody would like to argue that with me, then, I'm around. Be happy to argue it with you. Anyway, I'm going to take you to another technology, and I'm going to demonstrate it for you and prove we can send electricity pretty much any distance without any wires at all. And by the way, no EMF. Okay, now, as I said, we are using the electric utility company because of the grid system, primarily because the grid is connected to the economy. But we don't need the grid. We don't need the grid. Now, courtesy of a technology that was developed by a man named Nikola Tesla, Tesla again, we have in the back here a Tesla coil. This Tesla coil takes normal electricity, converts it to dielectricity. Now, by the way, dielectricity is the exact opposite of normal electricity. The exact opposite. Normal electricity travels over wires. You have to have two of them. One to go there, one to come back. You got to complete the circuit. You have to have two wires. But normal electricity rides over the copper, the metal. It has to have a conductor to ride. And so it rides through that conductor, and as it does that, it gets resistance. So the resistance that it builds up is the reason why you get EMF into the environment. When normal electricity rides wires, you get EMF, electromagnetic frequencies, and by the way, or fields, and by the way, that is definitely happening if you're anywhere near a high tension power line, and if you are, you should get out of there. You owe it to your children. That is an unsafe environment. Now, when you take dielectricity, the opposite of normal electricity, it does not ride wires or ride conductors, it rides an insulator. Now, the best insulator you can find is the air. So normal electricity rides wires, dielectricity can be sent through the air, and by the way, it goes through anything in its way. A herd of elephants, it would pass right through them, pass through a mountain, pass through buildings, it'll pass through any object, and I'm going to show you that in a minute. Now, dielectricity then rides the air, not copper. You don't need any wires. There is no resistance, so therefore there is no EMF. Nikola Tesla shot electricity 26 miles, got 99.9% of it there. I believe only because back in those days of horses and buggies, our instrumentation wasn't very accurate. But I think he got 100% of it there. Now, if I had a 30 kilowatt unit, put it on somebody's lawn, took a Tesla coil, put the coil right out here in front of that had the capability of sending 30 kilowatts out, it would send it in all directions, and the people in all the different houses, because the average consumer only uses 2 kilowatts an hour, had a 2 kW receiver, all your neighbors, then 15 homes could be powered by this, all electric homes could be powered by this unit with that one coil there, and all of those homes would have their own individual coil. There'd be no wires between this and all of those houses. No matter how far away those houses were, they'd all be receiving their electricity in a straight line with this coil. It would go out in all directions, find them, and set up a straight line. Power goes through the air, returns through the ground. So if that one was grounded, the other one was grounded, that would happen. Now, I'm going to prove to you that that is the case. We're going to make normal electricity, make dielectricity. I'm going to turn this variac on. And as I turn on this variac, you might want a wide angle so you can get that bulb in it, Mike. We have a bulb sitting over there, and we have going to that bulb a single wire, one single wire. Now, by the way, electricity can't pass over a single wire. It needs two. It needs one there, one back. Can't send electricity through a single wire. However, it goes there through the air. I'm going to prove that to you in a second. It'll go right to the bulb through the air. Then it's going to come back, go through the air, come back across the wire, which will ground it to this unit. Now, if this was grounded and that was grounded, we wouldn't even need any wires at all. Now, let me go ahead and tune it up, and as I do it, you'll see the light bulb light up. See the bulb light? Unlight, light, unlight, light. I'm controlling whether that bulb is lit or not from right over here. So now, if we watch me go from here, we've got the wire right here, and then I'm going to now walk over to the light bulb. Before I do, let me turn the light off. See the bulb fully lit. I'm going to walk. Can you see me, Mike? I'm going to walk. Okay, I'm going to walk to the bulb. Now, the bulb is sitting here. It's lit. Its power source is over there. There's a single wire, but I'm now going to grab this bulb. When I grab this bulb, I'm then going to be grounded back to the unit as well. So now I'm grounded to the unit. The power is coming from there to me, to my body, and it's going from my hands back to the grounding wire, back to the unit. So wherever I grab this, it will go from my body, I'm a Tesla coil, a human Tesla coil, all the way back down through the grounding wire back to the unit. So wherever I grab this, that's how much of this is going to be lit. All right, so we have the light back on now. The lamp is still lit. It's going from there back through the single wire. Wherever I touch it, that's how much of it is going to be lit. But I'm going to now show you something rather interesting. Now, if you see the perspective, the power is coming from right there to here, to me, and so I'm going to prove to you that walls, buildings, elephants, nothing would affect this, because right here I have a solid wall, and the unit is over on that side of the wall, yet it's going right through the wall. The signal is going to me, and it's going back from me through the wire back to the unit. So even through this wall, no flickering, no difference, because it'll go right through the walls and right through anything. Power will be sent in all directions. It will find this, and then it will go right back. Find this, and it will go right back to the sender. So in this manner, we don't need the grid system. We could even send this power down to a wire. It would ride the outside of the wire, the distance of the wire. So we do not need the grid system to be able to move electricity. Why are we offering to work with the electric utilities companies to use their grid? Because the economy is connected to the grid. And we do not want to destroy the economy of the United States or hurt the infrastructure of this country in any way. We've already shown you a lot of things. We've already shown you that we don't need the grid. And we could, of course, give you better illustrations. We've already shown you that we could give your electric utility company fits with a little technology that sent them back all the power they were sending to you and made you a supplier of energy. We've already discussed the fact that we did a show for the Congress of the United States and asked them to deregulate the electric utilities in 1996, and they did deregulate the utilities in 1996. We've shown you a lot. We've shown you about magnets. We've shown you how magnets could indeed be used, because we're building a case for free electricity. But what if there was a way to make electricity absolutely free? And by the way, God makes free electricity every time we get a lightning storm, doesn't he? But what if there was a way to make electricity absolutely free with no mechanical devices at all? Don't need a mechanical device. No generator, nothing to go around, nothing. No circuits. Don't need to go to Radio Shack, don't need to get any circuits whatsoever. No wires. No wires at all. No Tesla coil and no wires at all. Get electricity wherever you want it, however much you want, any time you want, day or night, anywhere on the entire planet. Impossible? Well, everybody likes to use that word a lot, evidently, and especially when they're talking about me. Too good to be true? They like to use that phrase when they're talking about us as well, because I guess for them some things are too good to be true. I'm a Christian. I believe that God says all things are possible, and He really means it. So I'm just going to show you a piece of videotape about a technology that's somewhere. Who knows where this technology is? There's a lot we're not showing you. We're not going to show you because we don't know how to show you without showing other people who could use that information against us. But I'm just going to show you some footage of a technology that exists. It's a real deal. It's an honest-to-goodness technology. Now, it's not a technology I would want to bring out because there's no way that your electric utility company could compete with this. But what if you could get all the power you wanted, wherever you wanted it, when you wanted it, in any amount that you wanted, and there was no mechanical device at all? You didn't even have to wire your house. Just put two little posts next to whatever device you want to run, hook it into the two little posts, and it would run and run and run and run and run until it burned out, and then hook a new one into the post and let it run until it burns out. Light bulbs, change the bulbs, no wires, take it with your lamp, and let your lamp stay lit all the time. In the ground, in a cavern, or otherwise. Now you're going to see that. Two little posts on a piece of wood, no wires at all. Perhaps if you think that everything I've said is too good to be true, you could explain this to yourself or to whoever is sitting with you if you're saying that you don't think that what we got is real. But I'm going to show you, you don't know everything. You really don't know everything. And at the end of this, the man is going to take those two little posts and cover them with a black cloth. It means no power could be coming from lights or anything. It's all blocked out with a black cloth. That means that if you took those down into an inside of a cave, they would still work. And he's going to show you they still work. All right? So this will just give those critics something really interesting to think about. So I'm going to just cut to that, and then we're going to come back, and I'm going to give you a little conclusion. But I think by now you should have been able to draw your own conclusions. All right? Now I'm just going to turn the film on and let you watch this piece of tape without any commentary from me at all. The quality of the film is not great because I've shown it to a lot of people nationwide. So I apologize to you for the quality of this videotape, but I think if you concentrate, you'll definitely get the picture and you'll be able to see it anyway, even though the quality of the film will not be as good as we would like it to be right now. Thank you very much for watching it.
Of course, don't want this on the market. It's just a wooden frame. It's got a auto switch on it right here, an automobile switch, which
I'm going to get closer.
okay, turns it off and on. I put a cover over it, a jar, to protect it. Now, it's compressed. The material in this is made of, one rod is made of 73 different elements. The other side is made of 74 elements. There's one additional element, and that's why one is negative and one is positive. One builds up electrons. The neutrinos that strike the Earth 24 hours a day and other things striking the Earth, the combination of them causes electrons to build up in one of these rods, and it depletes them in the other side. much like a solar panel works, very much like a solar panel. But a solar panel needs light 24 hours a day if you're going to use it 24 hours. Otherwise, it only works when the sun comes out. Now, this here, as you can see, very, very light, very light. Has practically no weight to it. But there's plenty of energy there. Now, as I run this up the rod, you can see.
Let me get a little closer there. Okay.
These are Christmas tree lights. 110 volt Christmas tree
Let me
lights.
get a good close-up of those lights. Let's see those lights again.
Okay.
All they are is what?
Just regular Christmas tree lights.
Yeah, but hold out your hand so I can see it a little bit better.
Okay.
The light bulbs. I want to see light bulbs.
Okay.
Without them being lit.
Oh, without them being lit.
Yeah.
Okay.
Just hold them there for a second. And all they are is grouped together and a little tape holding the ends out,
Yeah,
right?
they're just grouped together here. There's 3 of them together.
Okay. So now what you're
For
doing
the
is just...
purposes of something bright so people can see.
So you're putting one wire on one rod and one on the other. Is
One
that
on the
correct?
other.
Okay.
Just like negative and positive.
Now turn the rod sideways so we can see them individually.
Okay.
There we go. Uh-huh.
Now, it's not a battery because you cannot light these with battery. Now,
Okay.
and to show it's not a battery, anywhere you move it up and down the rod, the lights work. See? See, anywhere. Down here, all the way up. The same. Anywhere you want to put them, they work. Now, there's no power buildup here. Now, to show, let's take something a little bit bigger. This is a 25 watt bulb. It's 110, 25 watts. Now, let's see what happens when we put that on. Now, of course, it won't be as bright because this takes a lot of amperage, and the wattage. This here, the watts on this thing here is only about, right now, about 18 watts only, and this is 25 watts.
Now, do the rods get hot?
No, the rods don't get hot. The light bulb is hot.
Yeah, because it's...
It gets hot. Of course, you can't see the heat there, but now I'll give you a good shot of the light here.
Okay. Yeah, got it.
Now you need a very big battery to do that. If you want to do that with a battery, that's to show there's no power here as far as storage power. It stores a certain amount of electrons because it builds up. Now, let's cover them. We're going to cover them up. So now no light can get to them. So we can show they're not like a solar panel. Now let's turn the switch on. So the power is now going from the bottom terminals through the switch here to the top here.
Right, okay.
Now we use these 2 terminals on here because sometimes at the cave site we used to use this to charge the big battery. See? So that's why we put those terminals on there. Now let's black it out. See if we can still light it. See what I mean? You don't need light. So we're not getting it from the fluorescent lights here. We're not getting the power from the fluorescent lights.
Right.
All right, America's Declaration of Energy Independence. You're the jury, you're the judge. I don't care what the oil companies say. I don't care what the electric companies say. I don't care what anybody but you says. This is a decision for you to make. Do you want it? Do you believe it? Has anybody ever given more evidence of their ability to perform this miracle and to revolutionize the energy production in the United States of America? Has anyone ever done more? Has anyone ever shown more? Have we had anyone else who went on a tour across the United States 3 times? And in all 3 tours showed something to the scientific community that's never been shown before. Ran full-page ads in major publications, inviting all scientists to come. bring their instruments, and test those claims for themselves, and successfully did every single demonstration exactly as promoted and exactly as planned, and not one single individual anywhere came to those presentations, though they all had the opportunity to test it and tested it, and found it to be anything other than what we claim. Has anyone else ever done that? Has anyone else been willing to show you a technology and let you test the technology? Oh, sure, we get people who make claims. Will they let you test the technology? So you see, where are the scientists? Where were they? Where were the critics when we went on our tour? There's only one critic in this country that has an excuse, and that is that he is so obnoxious and he is so obvious in his quest, a man with a mission, to discredit me, that he has proven to me beyond any doubt he has no objectivity at all. And yes, that man can say he's been denied access to the very meetings. But he's the only one. No one else has ever been denied access other than the media. Because I don't do what I do for the media. I don't do what I do for the officials. I do what I do for you. You're who I'm interested in. I don't care what the scientists say. They're welcome to come. They're welcome to test. And then they're welcome to sit down and shut up. Because I'm not performing for scientists. I want a test from the mass, public awareness, the people in this country. I believe you are the one that is being denied technologies that can improve your life, and I believe that you are the one that can determine whether or not you should have an opportunity to let me prove to you with live demonstrations that I really can or cannot make this happen. Now, I've proven all the components. I've proven the motor on a national tour, 28,000-mile tour, 47 public demonstrations. Every man in the world had the chance, equal opportunity, to come to any of those 47 presentations and measure it for himself. I've done a show for the Congress of the United States to implore them to work with me to deregulate the electric utilities, to give independent power producers like myself equal access to the grid and the opportunity to work with the grid system, even though I don't need the grid system, as I've also proven. We're not here to hurt anyone. We're not here to tear anything down. We're not here to destroy anybody's opportunities. We're here to uplift, build up, make the world a better place. That's why we're called Better World Technologies. We're here to get the world the opportunity, the wonderful technologies that it had from its very inceptions of the production of electricity. We're here to right a wrong. It should have been the International Tesla Electric Company from the beginning until now, but we went with Edison because we wanted everybody to be on the end of a line and have them pay through their nose for electricity on a continuous basis, while all along, every one of us could have had free energy. Now, I don't know, maybe you think there's something wrong with that. I certainly do. Maybe you don't think there's anything wrong with that. Okay? I'm not here to eliminate your bill. I don't have any problem with people paying bills. I have no problem with you paying for your electricity. But I am here to stop all the fossil fuel pollution in this country. I am here to stop the negative effect on our environment trying to get energy. I am here to right a wrong. Now, either you think that I should have a right to go out and present my case, or you think I shouldn't. Either you think I should have the opportunity to do what the Wright brothers did and fly my airplane in public to end all of the ideas and all of the misconceptions about whether or not I could do that. I've never put the two technologies together. I never have. I have the one, it's proven, I have the other, it's proven, and common sense would tell you the two together could do what I claim. I believe it. Do you believe it? See, a case is presented in a court of law, and then the jury decides. That's what I've tried to do here. Give you the evidence. I've presented my evidence, maybe someone can present their evidence. But by the way, anybody who says you can't make free electricity already lost his case. You can't say what can't be done. You can discuss what has been done, but you cannot say this or that cannot be done unless you're God. Because it would take God, who knows all things, to determine what could and couldn't be done. But we've already heard from God. If you believe in Him, God has said in His Word, all things are possible. All things are possible. God has not said in His Bible, if it sounds too good to be true, it probably is. Because certainly salvation wouldn't qualify. Because that certainly sounds too good to be true. But I know it is true. So you decide. I've laid my evidence in front of you. Should I have an opportunity to have my witnesses all assembled across this country, should each independent republic of the 50 republics called the United States of America, should each of those republics have the right to decide as separate entities, have the right to decide the issue for their citizens? I think so. And I want to do 2 public demonstrations. But I want to have massive distribution, because the most shocking thing of all, this has already been proven in the United States of America in a court of law. And people use that case to try to claim that I'm a bad guy. When actually the fact of the matter is, I won that case. All the criminal charges were dismissed against me when I proved in a court of law that I indeed could make free electricity, and I did that before 1990, in the late 80s. So look at all the time you and I have missed on getting on with life and doing what we're looking at doing. And if you really think that it isn't important for us to have public awareness, maybe you could explain to me what happened in Ventura, California. So this is my case, and you're the jury. You decide. But I'll tell you one thing, I'm here. I will always be here. I am coming to the end of this, and when I get my witnesses, I will bring whatever I've got forward, and then we'll know. Help me, please.